Hello and welcome to Video 2, Instructional Design Principles. The principles we're going to discuss are those that help to reduce the extraneous cognitive load. Now, why is that a bad thing? Well, if we have extraneous overload, then the learner's cognitive capacity is exceeded. That means that their cognitive capacity is the total amount of cognitive processing the learner's working memory can handle at any one time. And when that gets exceeded, when that's too much, then the learning can't take place. Extraneous cognitive load can be caused by poor instructional design. Too much extraneous information, poor instructional design layout, or poor implementation of design. The three principles we will discuss in more detail and go through some examples and a demonstration of their application are spatial contiguity, coherence, and signaling. The spatial contiguity principle basically is that things should be near each other so that you're not searching for stuff. The bullet point and the illustration should be on the same slide. This will reduce the learner's need to scan back and forth between words and pictures. And this is really important when the material is complex or multi-stepped, according to Mayer and Fiorelli. Let's look at an example. Here, there's an excerpt about apple pie, and the picture is right with it. So it's very clear what we're talking about, and you don't have to go searching for the illustration. Now, why does spatial contiguity work? Well, basically, this principle, when it's applied, it helps learners find relevant information quickly. It focuses their attention in their direction. Extraneous overload is caused by poor instructional design, which would be a poor layout, and we want to avoid that by using the spatial contiguity. According to Mayer and Fiorella, the cognitive theory of multimedia learning states that the spatial contiguity will help learners use their limited cognitive capacity for processing. They want to process what's essential, what's needed, rather than wasting it on extraneous items. We want to have our learners working through problems. We provide them with a formula. But instead of having them flip through pages or go back several screens to understand what each variable means, just provide it right there next to it. That way, they're close to one another and it's relevant information, and their learners not wasting some of that processing, their cognitive abilities, trying to find the information. Our next principle is the coherence principle. What this basically means is we want to get rid of all the extra stuff. We want to eliminate the extraneous material. Now, Mayer and Fiorelli basically emphasize that it's time to stick to the essentials here. Many of us are guilty of this when we're teaching. A lot of times we go off on tangents, so we want to share cool facts. So let's look at this example. We're talking about and teaching our learners about guitars. We have some basic information about the instrument and the common ones used today. And then we have a cool little fact in there about Jimi Hendrix and what kind of guitar he played, and there's a picture of him. Well, that's really interesting. However, it's not necessarily helpful for the learner. So this part, the Jimi Hendrix and his Fender Stratocaster, aren't necessary. So we want to remove that. And then this photo of Jimmy, we want to take that out too. So why does that coherence work for us? Well, again, according to Mayer and Fiorella, less is more. Learners benefit when they can focus on the essential material and the need to know, rather than processing both the essential and the extraneous information. According to the cognitive theory of multimedia learning, we don't want to overload limited processing capacity and working memory. That extraneous overload, too much extraneous information, can be caused by overly detailed material or poor instructional design. And we want to avoid that using coherence. So let's look at our guitar example again, but this time let's look at it done so that that extra information, the cool to know, is not there, and the picture has been replaced with something that's appropriate, and it's actually an illustration of the facts, the classical, electric, and acoustic, because someone not familiar with guitars may not know that what they look like and the difference between them. That's the coherence principle. Let's move on to the signaling principle. According to Van Gogh, the signaling principle serves several functions. One is highlighting organization of the material or the relationships between different elements. And the other, of course, is getting the attention of the learner to those relevant elements in the material. Because without proper design, unimportant features might grab the learner's attention, and we want to provide signals or cues to help guide the learners. So let's take a look at another example. We're teaching our students or our learners about football plays. And here it says the quarterback can either hand off the ball or keep it and run himself. Well, if you're not familiar with the markings for football plays, it may be very unclear who the quarterback is in this drawing. So that's where signaling comes in. Now we can clearly see which item of these X's and O's represents the quarterback and what exactly is it we're trying to get from that. So why does the signaling principle work? Well, if we have too much extraneous information, it can cause overly detailed material or poor instructional design. All of this can cause that extraneous overload. So what we want to do is we want to help the learners to use their limited working memory capacity. We want to help the learners to select and organize and integrate the information that they're getting presented in the materials. We want to use our signaling cues to emphasize relationships between elements in the text and the pictures. According to Mayer and Fiorella, the cognitive theory of multimedia learning states that learners can focus more on processing essential material in working memory and less on all the extra material or trying to sort out what's important and what's not. It's important for them to be able to focus and use their cognitive processing on the essential information. So here's an example of a formula that's provided, the compound interest formula. And there we have all of the different variables spelled out and what they are. And it's a decent example, but let's make it better. Let's signal a little there. We have the same formula, we have the same definition, but now the signaling, the arrows draw us in and it makes it very clear what part we're referencing when the definitions are expressed. Now at this point, we're going to go through an example. Now this is a real live example from my work, and basically there were these 3 slides that were jam-packed full of information, and I'll show them to you. And we want to compare it with the updated slides. So here is an example of the first slide, and it has the pink banner on the top. And then when I get to the updated slides, they have the gray banner on the top. So let's go through the previous examples. Here's the first slide. Lots of information presented, bullets. You know your students and learners are going to be reading through this. Not a lot going on, telling them what's really important or what sequence of events to do. Now the second one has pictures. It has some signaling. It tells them the steps and sequence, but it's a lot going on one slide there. And then the third slide, we're back to bullets and information. The phone numbers are highlighted a little, but that's the gist of it. Now let's go through the current slides that incorporate these 3 principles so that we can reduce the extraneous load of our learners. And I'm going to start just going through the lesson as if I was teaching a class. So in order for our students to access the DAU Guest Wi-Fi, because this is available for any students who bring their own devices, you need to be sitting in a class, registered, and at one of our site facilities. But any of the Wi-Fi enabled devices are accessible and can be connected. You can use a tablet, a laptop, or your phone. Now, what does it provide access to? Well, it's important to know that there are some limitations. You can go to any of our DAU website, for example, iCatalog. Many of you use these when you're looking for classes or checking for your certification standards. You can also go to other government sites, other commercial sites, other .mil sites. However, the restricted .mil sites are not accessible through DAU Guest. So now let's see the steps you need to take to connect. First, you want to go ahead and select DAU Guest. Then you want to enter the password, and it is student at DAU. However, just pay particular attention to the capital D and the number 3. Then you're going to have to enter the login. And here we want to select the student login vice the visitor login. Now, if you've forgotten your username and password, please retrieve them from this site. We all usually access our devices on a day-to-day basis with our CAT cards, so we've forgotten our username and password a lot of the time. But we each have one. Anybody who's been registered for courses has one. So if you need to retrieve it, we can do so on the break. And if not, if you know it, then you can just proceed from here. You'll enter your username and then your password. Now that you're able to use your own device and connect, you'll be able to connect on our DAU guest Wi-Fi on site. Please let me know if you have any problems. So that was basically an example showing the difference between the slides in the beginning, where we had a lot of information just kind of bulleted out, and then a lot of directions on one slide, vice the application of the different design principles to reduce our extraneous cognitive load. In particular, we were looking at spatial contiguity, where related words and pictures should be placed near one another, coherence, where we remove all the extraneous details and we just stick to the essentials, and signaling, where the cues direct the learner's attention. The DAU guest slides demonstrated how to implement these principles, and we also went through several other examples. Just remember, as an instructional designer, we need to be aware of the limitations of working memory and apply principles to reduce learners' extraneous cognitive load whenever we can. Thank you for joining me today.